Hello, these are the exercises for section 5.4, probability and the addition rule. A survey of 400 randomly selected adults at Solid Community College determined that 287 were taking a math class. What is the probability that a randomly selected student is taking a math class? Interpret this result. So we have the probability that we're taking a math class. It's going to be the number of math takers over the total that we surveyed. So it's going to be 287 over 400, and that is 0.7175. So this means that if we surveyed 100 students, we'd expect about 72 to be taking math. And how we got that is we took this 100 that we had, 100 times our probability, 0.7175, and we get 71.75, which is about 72 students. These next few exercises are about a standard deck of cards. So there are 4 suits, the clubs, spades, hearts, and diamonds. Okay, there's 52 total cards, and within each of these suits, there is an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, a jack, queen, and a king. Cards that have a face on them are called face cards, and otherwise they're just cards. Okay, so with that information, we're going to go through and do some probabilities. What is the probability of pulling out a face card? So the probability of a face card is the number of face cards out of our total. So we had 52 cards total, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 face cards. This can reduce to 3 out of 13, but typically the unreduced fraction will be sufficient, or we're going to go through and we're going to round our probabilities to the nearest 4 decimal spots. They may also like you to use a decimal approximation. Okay, so here we have the probability that we have a heart or a spade. Okay, so this is an or, this is a compound probability. So we've got to think about, oh, since we have an or, we're going to use the addition rule. And we have to determine whether or not these 2 events are disjoint or not. So you want to think about, can you simultaneously be a heart card and a spade card? Since you cannot, they are going to be disjoint. Therefore, we have probability of a heart plus the probability of a spade. Heart's going to be the number of hearts that we have out of our total. Probability of being a spade is going to be the number of spades that we have, 13, out of our total cards, which is 52, which is 26 out of 52, which is 1/2, or 0.5. Okay. I want you to notice that you could have thought of this as a single situation, like a single event, and been like, how many times in my deck of cards could I get a spade or a heart? And there'd be 26 out of 52. So oftentimes you can go through and calculate these without the addition rule, but the addition rule, especially when they're not disjoint, is much more straightforward. So this next question is the probability of a 2 or a 3. So again, we have an or, so we're going to have the addition rule. And then you got to think, can I simultaneously be a 2 at the same time that I'm a 3? And you can't, so they're going to be disjoint. So you want to look up your deck of cards and you go, how many times can I pull out a 2? So there's going to be these 1, 2, 3, 4 out of the total of 52. So we're going to have 4 out of 52. Probability of being a 3 is going to be the number of times we have a 3. Again, is 4 out of our total, which is 52. So 8 out of 52, which can reduce to 2/13, or we approximated with 0.1538. So now we're going to do the next one, the probability that we have an ace or a heart. Okay, so we have the or, so we're still going to have the addition rule. But then you got to go through and think about if these two events are disjoint or not. So looking up at our sample space, can we simultaneously be a heart and an ace? We can, right here. And therefore, these two events are not disjoint. So we're going to have the probability of an ace plus the probability of a heart minus the probability that we're an ace and a heart simultaneously, because we don't want to count that double twice. So probability of being an ace, there are 4 aces out of a total of 52. Probability of being a heart, there are 13 hearts out of a total of 52, and there's 1 ace of hearts out of 52. So we have 16 out of 52. This reduces to 4/13 and approximates to 0.3077. Probability of a face card or a diamond. Again, we have an or, so we're going to be using the addition rule. And then diamond or face, are these disjoint events or are they not disjoint? So let's come up here and look at our sample space again. Can you simultaneously be a diamond and a face card? You can at these 3 cards. So there is an overlap, and so therefore they are not disjoint. So probability of a face card plus probability of a diamond minus the probability that they are simultaneously a face card and a diamond. Probability of a face card, remember we had it up here, it's 12 out of 52, plus probability of a diamond, there are 13 diamonds out of a total of 52 cards, and then minus the times that we are a face card and a diamond simultaneously. So we're going to have these 3 cards. So we have 3 out of 52. So we have 22 out of 52. So 11/26, which is approximately 0.4231. The next exercise is a bag of tulip bulbs contains 30 red tulips, 20 yellow tulips, and 10 purple tulip bulbs. Okay, so what is the probability that a randomly selected tulip is yellow? So again, it's the number of yellow over the total that we have. So we have 20 yellow tulip bulbs over 30 plus 20 plus 10, so that's over 60, or 1/3, or 0.3333. Again, when you do your approximation, you should determine how many decimal spots you're supposed to round to and make sure you do that. What is the probability that a randomly selected tulip bulb is purple? Okay, so probability of purple is a number of purple over the total. The number of purple, there are 10 purple tulip bulbs. Over the total, it's still 60, which reduces to 1/6, which approximates to 1.1667. Then you want to interpret this. So what we would do is, since we have 100 tulip bulbs, we're going to go through and have 100 times 30.33. So we have 100 times 0.333. So it's going to be 33.33. So if we had 100 tulip bulbs, and they were sampled, one would expect about 33 of them, of the tulip bulbs, to be yellow. And we're going to 100 times 0.1667, that becomes 16.67. And we'd approximate about 17 of them to be purple. Suppose chips are randomly selected out of a bag. Each chip is labeled with the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we have our chips 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Just to kind of help us to visualize it. Let event E represent the event choose a number less than or equal to 2, and let F represent the event choose a number greater than or equal to 8. Compute the probability of E or F. So the probability of E was a number less than or equal to 2. And F is a number greater than or equal to 8. So again, we have an OR, so we have to use the addition rule. And then we got to think about if we are disjoint or not disjoint. Can you simultaneously be less than or equal to 2 or greater than or equal to 8? You cannot. So we're going to be disjoint. So probability of x less than or equal to 2 plus probability of my chip being greater than or equal to 8. Here we have 3 out of a total of 10 plus 2 out of a total of 10. Or a half. Okay. Suppose chips are randomly selected out of a bag. Each chip is labeled the same as that was before, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let E represent probability, the event choose an odd number, and let F represent the event choose a number less than or equal to 4. Compute the probability of P or probability of P or F. So we have it's odd, or our number that we choose is less than or equal to 4. So we're looking up here at this situation, and we have to think about, can we be odd? So here we have odd. And then we have a number is less than or equal to 4. And so therefore, you can see that they can simultaneously happen. So, or we're going to use the addition rule, but they are not disjoint. So we're going to have a probability that we're odd plus probability that we have x less than or equal to 4 minus probability that we have simultaneously odd and x is less than or equal to 4. So we had 1, 2, 3, 4, 5 out of 10 odds, plus less than or equal to 4, 1, 2, 3, 4, 5 out of 10, minus odd and less than or equal to 4, and there's these two that are both underlined and circled, so we have 2 over 10, so we have 8 over 10, which reduces to 4/5, and is 0.8. Okay. And if you look at this, you can see that 6 and 8 are the only ones that aren't going to possibly be selected, and so there's 8 that could be selected under these events, and therefore that's why the probability is 8 out of 10. This last one is, suppose a standard 6-sided dice is rolled. So on the dice we have sides 1, 2, 3, 4, 5, and 6. Find the probability that the number rolled is an even or a number less than or equal to 3. So again, we have an or, so we have the additional. And then when you think about, can I simultaneously be even, which are like numbers like that one, and that one, and be less than or equal to 3? We can, and so therefore we are not disjoint. So probability of even plus the probability of x less than or equal to 3 minus probability of even and less than or equal to 3. So the numbers of even that we have were, so there was 3 out of 6. The numbers that are less than or equal to 3, there's 1, 2, 3 out of 6. And the number that is even and simultaneously less than or equal to 3, there is 1 of those. So we have that as 5/6, which is 0.8333. Okay, thank you.